Okay, hi. So in the previous video we had a look at the tests for different positive ions, and so it follows that in this video we're going to have a look at the tests for the negative ions. Okay, and so we can break down these negative ions into three categories, and that's what we're going to be looking at. And those are the carbonates. Okay, the carbonates, and these are the ones that contain the CO3 2- ion. Okay, so things like calcium carbonate, okay, potassium carbonate, they're all going to contain CO3 2- as an ion. Okay, and we're going to test for those. The second one are the halides. Okay, now the halides, broadly speaking, we're just going to say X-. Now that X stands for anything which is in group 7 of the periodic table. Okay, so that includes fluorine, chlorine, bromine, iodine. Okay, so that's going to be fluorides, chlorides, bromides, and iodides. Okay, and lastly, we're going to test for the sulfates. Okay, and this is spelled differently depending on whether you're using the English or American spelling. Okay, now they contain the SO4 2- ion. Okay, that means that you have a sulfate. Okay, and so first of all, we're going to have a look at the test for the carbonates. Okay, now this is a very simple one to remember. All we do is we add dilute acid. Okay, so we add dilute acid to our sample which we are testing, and if it contains a carbonate, okay, then we are going to get fizzing. So fizzing equals carbonate. Okay, this isn't true all of the time, but for this course it's good enough. Okay, so if you add dilute acid to something and it fizzes, you've got a very good chance of it being a carbonate. Okay, and that fizzing is given off carbon dioxide as a gas, and we can represent this in an equation which you need to know. You'll know that an acid, okay, is something that produces H+ ions. Okay, so H+ tells you it's an acid, and if we add that to a carbonate ion, which is obviously what we're testing for, so if this is actually in there, this is going to happen. Okay, then we are going to get carbon dioxide given off as a gas, okay, CO2, and also water given off, okay, and H2O. So this isn't balanced, you'll realise to start with. I'm just going to put the state symbols. We've got aqueous acid, aqueous carbonate, gives off CO2 as a gas, and this here, okay, is what causes the fizzing. So I'll just put an arrow there. Fizzing is a result of that CO2 gas, and liquid is obviously written as L. Okay, and if we are to balance that, we just need 2 of these hydrogens here, okay, in order to give us our 2 hydrogens in the water. Okay, and this is known as our Ionic Equation. It's not the full chemical equation because we haven't showed which carbonate it is and which acid it is. Okay, we're just using the important parts, showing the general Ionic Equation. Okay, and so next, the halides. So the halides, the order of this one is very important. Okay, so what we do first is we add nitric acid. Okay, so we add nitric acid. Okay, and it's going to be dilute. The reason we do this is so that we can get rid of any carbonates. Okay, I'm going to put that in brackets. Removes carbonates. Now those carbonates would interfere with the rest of the test. Okay, so we add nitric acid first in order to stop that from happening. After this, we then add silver nitrate solution. Okay, so silver nitrate solution. Now this is going to form a precipitate which is made of the halide and the silver. Okay, so silver has the chemical symbol Ag. Okay, so we've got AgX, and that's going to be our precipitate. Okay, this is a general equation, general formula, and that X is going to be our halide. So fluorine, chlorine, bromine, iodine. Okay, we don't really talk about fluorine because fluorine's extremely reactive and other things might happen as well. So generally, we only talk about chlorine, bromine, and iodine. All right, so we can also distinguish between the 3 halogens. Okay, depending on the colour of the precipitate that we form. So I'm going to write precipitate equals, okay, chloride is a white precipitate, bromide gives us a cream coloured precipitate, and iodide gives us a yellow coloured precipitate. Okay, and so the white, cream and yellow would tell us do we have a chloride, a bromide or an iodide, once we know that we've definitely got a halide. Okay, and just like in the last one, I'm going to quickly squeeze the ionic equation, okay, in here. So the ionic equation is therefore our silver. Okay, the silver is obviously positively charged in solution, plus our negatively charged halide in solution will form the solid precipitate. I'm just going to put that in straight away. Silver halide. Okay, like so. So silver ions plus halogen ions, which are halides, gives us this precipitate. Okay, so finally the sulfates. Okay, and this is going to be similar, okay, to the last one to start off with, because we're going to add two things. First of all, we are going to add dilute hydrochloric acid, okay? So dilute HCl aqueous, that tells you it's hydrochloric acid. And this, again, just like the nitric acid in the last one, is to remove carbonates. Okay? We didn't use hydrochloric acid in the halide test because that acid would also react with the halides, okay? So we don't want that to happen, so we use nitric acid. In this case, we can use hydrochloric acid, which is just fine. Okay, and then after that, we are going to add a barium chloride solution. Barium chloride solution. Now, if we get a white precipitate, so a white solid, that tells us that we had a sulfate. And this white precipitate is now barium sulfate. So, I'm going to write the ionic equation for that. Ionic equation. And that is going to be our barium ions. So they are 2+. These are in solution, because it was barium chloride solution, plus our sulfate ions. So if we have sulfate ions, this is going to happen. Okay, it will give us barium sulfate as a precipitate, which is therefore a solid. And this is what we see. This is the white precipitate, and that is why we can use the test. So I'm going to stop there. That was just a brief overview of the three tests. I hope that's helped, but if you do have any questions, please feel free to send me a direct email using the link below, or post a comment. I'll be sure to get back to you. But as usual, please like and subscribe, because there are more videos coming very soon, and I look forward to seeing you in the next one.